Hello students, I would like to describe you some features of a C++ user-defined data type called structures or records. And I'm using this Wacom tablet for annotations for the very first time, so I'm going to mess up quite a bit, but as long as you understand what I'm talking about, everything will be okay. Well, we did a homework on grading true-false choice test, and I did it in class. Another example, grading a multiple choice test where we use multiple arrays, okay, which are called parallel arrays. And it was mentioned at that time that first element of each array will be related in a certain way in order to form a record of some kind, and you can work with arrays to do that. But there is a problem with those constructs, that if somehow one array got messed up, all the records will get messed up. So really it's better to keep all the related data in one place, and that is doable by defining something called a struct. Okay, so we'll see what a struct is very soon. And this is what I was talking about, that if you have an array, let's say ID number and the GPA, and GPA for ID number 4562 is 3.7, GPA of ID number 1235 is 2.8. As long as these parallel arrays remain in the same order, like we know for sure that this data is for 4562 and this data is for ID 235, everything is okay. But that may not be the case if any of this array got messed up. Let's say it got sorted or something, or some positions were changed, then the whole thing will be messed up actually. So this is fixed by a construct C++ data type called struct. Alright, so let us give you a simple example of struct first. What I want to do, I have a struct here, but I'm going to do something simpler than that. Let's say struct student. Alright, so let me do one thing here. I'm going to pause the video and insert a page and then go from there. So imagine that we are keeping students' data. Students' data could be their first name, last name, ID number, and age on the last birthday. Okay, so one option will be to create 4 parallel arrays, one for the first name, one for the last name, one for ID, actually 5 parallel arrays, ID, one for GPA, and one for the age. But we're not going to do that. We'll simply declare something called a struct student, left curly brace, and here I'm going to skip ID. I don't want too many fields, so there will be a string last, that is the last name. There will be another string first, that's for the first name, int age, which is age on the last birthday, and double GPA. And then what happens is that we enclose the struct by curly brace but terminating with a semicolon. Okay, that's something you have to remember. That so how are struct defined, and there are no upper cases anywhere except this one. So So struct is defined with the keyword struct, struct name, left curly brace, first member of the struct, which could be any data type, second member of the struct in this case, third member of the struct, fourth member of the struct. And notice these are regular declaration like you do inside the main method. Closing curly brace and the semicolon. This is very important. Don't forget that. Okay. When you do something like this, it is not creating a location in the RAM. It is simply a template from which you can create a student type of instance later on, and of course you will later on fill these fields. So in summary, a struct has a type or name, and it has the struct members. Just like array has array cells, structs have members. So basically struct have name and members. All right. Typed in Visual Studio, struct student will look like this. The keyword struct. This is the name I picked, student. Left curly brace. String, which is store the last name of the student. String, that will store the first name of the student. Age, that will store the age on the last birthday. GPA, that will store the current GPA. And again, once again, don't forget that this semicolon is required. Okay, declaring this declaration is done outside the main method, so that main and any other method that I might have after the main can see this definition. This is user defined data type. It's not stored inside the C++ unless you do this definition here. Only after that it's available, only in this file, nowhere else. Okay, so that's why structs are defined outside the main as a standalone data type or entity. And this does not assign any excuse me, any RAM. There's no variable of student type have been declared yet. The variable declaration of a student type will be done like this. Student S. Now a variable of student type S has been declared in the RAM. Its contents are undefined because we have not assigned any value to last, first, age and GPA. But now on this line it has been created. So there will be in the RAM a object called S, which I can work with. Alright. Okay, so we have explained how a struct is defined as a data type, how an instance of a struct is created. Alright. So next goal is for us to understand the access mechanism for the struct member. How do we access these struct members? Member of a struct are accessed using something called a dot operator. Okay. If I have a struct that I did up there, or this struct here, which has student type, last, first, age, and GPA, and I declare student S, then following happens, that S dot last gives me the access to the member last name. S dot first gives me access to the data member first. Okay. Similarly, S dot age gives me member access to the age member, and S dot GPA gives me access to the GPA member. Okay. So let's go to Visual Studio and do all this over there. So at this line, nothing is there in the struct. It's undefined values. So we do s dot last and set the last name to something, some value. Let's say Doe. Then I do s dot first and set that to, let's say first name is John. And then I say s dot age equal to, let's say 30, and s dot GPA equal to, let's say 3.4. As soon as I do that, the members have been populated. Okay, in a minute we'll actually build a graph, some sort of diagram for you to show you how these members are populated. Let's actually do that real quick. So let's see, after we have created a instance of student type S and set these values, which means last name fields to Doe, first name field to John, age field to 30, GPA field to 3.4. Let's see how in RAM this will look like. I'm going to do a hand-drawn picture and you will see how that looks like. It will look basically like what you see here. There will be a space in the S object for the last name, and since we did S dot last equal to Doe, last name Doe will be stored in that field, and you can see that by going to the source code here, this one over here. Okay, since I did S dot first equal to John, the field for the first name will store John. Since I did S dot age is 30, field for age, which is this one here, will store 30. And since I did S dot GPA equal to 3.4, field for GPA will be 3.4. So that's how members of a struct are initialized. Using the dot notation, we get the member access, and then when we place a value on the right hand side, those get stored, and the composite pictures of the object S will look like this. Okay, so what we have done in this video, we have shown you how to create a struct or a record, which is user defined data type in C++, how to add members to the struct, where should we place it in the program, like before the main in the global area, how to select members of the struct using dot notation, and how to populate them with the values. Okay, so that's the introduction to the struct declaration. We'll continue on in the next video. Thank you.